That's 10 to 100 times more than at the poles. Additionally, Neptune undergoes seasonal changes that increase the size and albedo of its cloud bands in the southern hemisphere. Additionally, researchers have posited that there is a direct relationship between Neptune's long orbital period and why seasons typically last 40 years. Neptune is by far the most distant planet in the solar system and is very distant from the Sun, at a distance of 4.5 billion kilometers. Every 165 years, the planet makes a forced orbit around the Sun. It is clear that the two partners are not the best of friends. Despite the strained relationship between the two partners, Neptune still receives energy from the Sun. However, the planet radiates twice as much energy as it received from the Sun. This discovery was a shock to scientists, as they could not explain how a planet that is 50% farther from the Sun and receives only 40% of the sunlight has enough internal energy to create the fastest planetary wind in the solar system. They're even more troubled by the fact that Neptune is hotter than Uranus. Based on precedent, Uranus should be hotter because it is farther from the Sun. However, this is not the case, and we see evidence of this when we take a quick trip to the upper regions of Neptune and the troposphere. Here the temperature can drop to 50.8 Kelvin. We will also see that at a depth of 1 bar atmospheric pressure, the temperature is 72 Kelvin. If we decide to go deeper into the gas layers, we will see a constant increase in temperature. Scientists are still puzzled by the fact that Neptune is hotter than Uranus, even though it is the farthest from the Sun. As they pondered the answers to these questions, they were struck by even more shocking discoveries about Neptune's moon Triton and its satellites. In the world of natural satellites, Triton stands out from the rest. It is Neptune's largest natural satellite and the first to be discovered by scientists. Located about 4.5 billion kilometers from the Sun and less than 4.4 billion kilometers from our beloved planet, Triton is very far away from us. This answers the question of why it has been so difficult to observe Triton with a telescope from Earth. However, the Voyager 2 flyby of the Moon in 1989 and the use of telescopes on the ground and in space have given us enough data to create a picture of this fascinating lunar world. Since Triton was discovered on October 10, 1846 by British astronomer William Lassell, scientists have never tired of the mystery that is the Moon. Almost everything about Triton is mysterious, especially because this is the only large moon in the solar system with a retrograde orbit. Simply put, Triton's orbit lies in the opposite direction of its planet's rotation. Unbelievable. Interestingly enough, if Lassell had not used his 24-inch aperture telescope to observe space, it would have taken us much longer to know about the existence of this magnificent natural satellite. Likewise, our understanding of the satellite and Neptune itself would be limited without the age of sophisticated space observing instruments. The appearance of space telescopes helps collect data about mysterious satellites. Scientists had barely recovered from the shock caused by this feature when their investigations revealed that Triton is the 7th largest moon in the solar system with a diameter of 2,706 kilometers, named after the Greek sea god Triton, son of Poseidon, the Greek equivalent of the Roman Neptune. Triton is larger than the dwarf planets Pluto and Haumea. Researchers find it interesting that Triton accounts for more than 95.5% of all known mass orbiting Neptune. This also includes the planet and its rings and 13 other known moons. Triton sits comfortably at a distance of 354,759 kilometers from Neptune and completes an orbit around the planet in 5,877 days. Scientists find this interesting because it is equal to the time it takes for a satellite to rotate around its axis. This means that one side of Triton is always facing Neptune. If we take a quick visit to Triton today, we will see one side of the moon shrouded in eternal darkness while the other side is bathed in eternal sunlight. It's quite fascinating. Our visit will also allow us to observe the moon's rather thin atmosphere. Based on observations from the Voyager 2 spacecraft, Triton's surface pressure is 1.4 to 1.9 pascals. This is very low compared to Earth's surface pressure of 101,325 molecular nitrogen, N2, carbon monoxide, and small amounts of methane that make up Triton's thin atmosphere were also detected during the flyby. However, recent space observations have revealed that these gases are present in lower concentrations than our previous observations. The discoveries don't stop there. There is also thought to be frozen carbon monoxide and carbon dioxide on Triton's surface. The most shocking discovery for scientists was the possible presence of argon on the Moon, that it's no wonder we can never get enough Triton. We also discovered that the Moon shares an interesting feature with Saturn and its moon Enceladus. Triton is geologically active and has geysers that are thought to produce nitrogen. Scientists believe that the power of the geysers comes from the heating of liquid nitrogen underground. If we look into space, we will see that the temperature on Triton's surface is as high as 35.6 K, making it one of the coldest objects in our solar system. That we could go on and on about Triton's amazing features. But our main concern is the recent shocking discovery of a major problem on Neptune. Scientists have not yet recovered from the shock of this discovery. You may wonder if it is possible to reach such a glorious planet. Of course it is possible. Scientists have discovered that the gradual disappearance of Neptune's clouds has turned the planet into a ghost. Observations of Neptune using the Hubble Space Telescope show that the planet has lost its majestic clouds, and we don't know why. Theories have been put forward that there may be a connection between the Sun's 11-year solar cycle and Neptune's diminishing clouds. However, scientists cannot fully explain what is causing this worrying phenomenon. We used to know Neptune for the brilliant white clouds that grace the planet's atmosphere. These clouds are mostly composed of frozen methane and contribute to the planet's fascinating appearance. We recall how Voyager 2, during its flyby in 1989, captured stunning images of these bright clouds, giving us a stunning glimpse into Neptune's dynamic atmosphere. Unfortunately, in recent years, we have witnessed a gradual but alarming decline in the presence of these majestic clouds. Observations by the Hubble Space Telescope have shown a significant decrease in the number and brightness of clouds in Neptune's atmosphere. This mysterious phenomenon has left scientists puzzled and worried. If we think back to the time when the first images of Neptune's atmosphere and the atmosphere of Neptune were taken during the Voyager 2 flyby in 1989, we see that there are many types of clouds forming, including bright white clouds and dark spots.